Hello all, today in this video I'm going to work with another optimizer with the LSTM. Mostly with the LSTM all the optimizers are providing the same results only. So for that first we are importing the libraries which we are needed, and then we are in this work we are using the email spam detection dataset. This dataset we downloaded from Kaggle. You can just give us email spam detection dataset Kaggle means you will get this dataset. This dataset is having nearly 3002 entries. Among that, the first 3001 entry we will be using for the X variable, and the other entry, last entry, which is the prediction entry, we will be using for the Y variable. Then we are getting the info of the dataset. From that, you may notice that only the one variable, that is the email number, it is object and all others are integers. Then we are checking whether our data set is having any null entries. Since it is everything is showing 0, you may notice that our data set is not having null entries. If it is having any null entries means we have to work with some pre-processing function. Then as I said previously, we are determining the X variable and also the Y variable, and within the X variable we are using the every 3001 to 3001 entry, and within the Y variable only the last entry is used. Then based on this X variable and Y variable, and the test sizes point to, that is 20% for testing and remaining 80% for training, we are determining variables like X train, X test, Y train and Y test, and also we are using the train test split function. Then we are using the standard scalar for conversion of vectors within the variables like X train and X test. Then we are getting the shape of X train. Why? Because this input shape we have to call within our layers input shape. So we are getting the shape of the data, but if you notice means we have to use three-dimensional data. So we are converting our through dimensional data into three-dimensional by the use of this reshape function. So this 3000 comma 1 only is used within the input shape of the LSTM layer. So this is the layer contribution of the LSTM layer which we are using. So it is having an LSTM layer with a filter size or kernel size as 64. Then the input shape as 3000 comma 1, and return sequences as true. We are also using another LSTM layer within I. So here also the same descriptions, but we are not using the return sequences too. Then two dropout layers we are using in line 4 and 6. The first dropout layer is using the dropout rate of 0.5, and the second dropout layer is using the dropout rate of 0.3. Then final dense layer, here the output dimension is 1 and the activation is sigmoid. Why 1? Because since this work is a binary classification work, since mostly in binary classification work we will use the dense layer as 1 only. If it is a multi-class classification work means this will be 1 will be replaced by the number of classes or we are having. So then mostly in a binary classification work, we will give the activation as sigmoid only. Then we are making the summary of the LSTM layer distribution we are made. Then we are compiling our model by loss. Optimizer we are using Adam, and then metrics as accuracy. Then we are training our model by using the fit function, and with the variables like X train, Y train, approaches for 5. Why only 5? Because this LSTM will take some time. If you notice means for one approach itself it is taking nearly 815 seconds. So it is taking some time. So only we have just reduced the number of approaches, and batch size is 32. Validation data as X test and Y test, and then we are determining the variables like loss, accuracy, validation loss and validation accuracy. Then we are determining the classification report for parameters like precision, recall, F1 score and support. Then we have made a definition for confusion matrix, and by this definition we have plotted a confusion matrix for Adam optimizer. Then we worked with SGD optimizer. Everything remains the same, but only the difference you might find is the name. Because if we will be making a comparison, within the comparison, if you are using the same name, means it may create some issue. So only we are giving only some name differentiations. Also the other differences, previously the optimizer name we will be using as Adam, now we will be given as SGD. So we have determining the confusion matrix plot, then also the classification report. Here also we are gaining 68% accuracy only. And then we worked with the rmsprop optimizer in this code. So the difference you may notice is that name of the LSTM. Previously it will be yes, now it is R, and this R we are making in the compile function, and based on that the optimizer also changes RMS prop. Then we are defining the classification report and also the confusion matrix. Then we have made a comparison. By this comparison, since here also you may notice the accuracy is 68 only. So mostly in every LSTM, though we are changing the optimizers, there is no change in the accuracies. So everything is same only. So if you notice here in the graph, means also if you notice, since now we have done with RMS prop, it is with a flipping color, and it is only in the first thing. Here also if you notice, means mostly all three are merging. Likewise in last two. In the next algorithm, we will be working with some other the LSTM work which makes some difference. Thank you.